Welcome to GlobalTutors YouTube channel. My name is Prince Williams, popularly known as Angelofmaths. Now today we'll be looking at the course Maths 201. We call it Partial Differential Equation 1. Now in Maths 201 we have series of topics like partial differentiation, domain and range, directional derivative, tangent to plane, normal line, and so many of them. Now for you to be able to solve these very topics that I have mentioned now, you need broad knowledge. Okay, you need broad knowledge in partial differentiation, because if you don't know how to differentiate any given mathematical expression, if you don't know how to differentiate it partially, you will find it difficult. So I will try my possible best to make this class to be interesting and to remove your naive, okay, in partial differentiation. So let's get started. Now before we start, I would like to explain one or two things, okay, based on what you already know. Like for instance, now let us consider, let's say, ordinary differentials, okay, or total differentials. So let us consider this. If you are given that y is equal to 2x, okay, because I know that you have seen this type of thing and you know how to do it. If you are given that y is equal to 2x and you are asked to find the y dx, you are asked to differentiate. You are not differentiating partially, rather you are differentiating totally, okay. You want to get the y dx. Now this is your constant. 2 is a constant. Whenever you are differentiating totally, your constant, you don't normally touch it because it is immaterial, it doesn't matter, okay. You can just leave it there and work on the algebra you have. So if we are taking the y dx, 2 is a constant, I will keep it, I will concentrate on the x. Once I differentiate it, I will get what? 1. So my answer will be what? 2. So let's consider another thing that you know. Let's say we are given that y is equal to, let's say, 4x to 6. Now I want to differentiate this. 4 is a constant, I'll just leave it. Where I'm going to pay much attention is the x. So I'm differentiating my y with respect to x. So once I do that, 4 is constant times, if I differentiate x to 6, I will get 6x to 5, in such a way that 4 times 6 will give us 24. So this will give me 24x to 5. Now, this principle is applicable in partial differential equation, but you need to use your sense, okay? You need to use your sense. Now let's assume, now let's get into partial differentials. So for instance now, if you are given that a function, let's say a function that has two variables, let's say x and y, such that this is equal to xy. Now you are asked to differentiate the function with respect to x, or you are asked to differentiate the function with respect to y. This is exactly the same thing with this, but the difference there is this. In this one, in partial differentiation, if you're working with respect to x, y will be your constant. Like if you're talking about this now, if I'm giving this, if I want to differentiate this now, 2 will be my what? Constant. Now if I'm differentiating this with respect to x, y will be taking the position of 2 here, and if I'm differentiating this with respect to y, s will be taking the position of 2 here. So what do I mean? If I differentiate this function partially with respect to x, my constant here is y. I will write y. Then I will differentiate s. I will get 1. My answer will be what? Y. Okay. Now, if I'm differentiating this with respect to y, my constant here now is what? X. Then I will differentiate y. I will get 1. So my answer will be what? X. So total differentiation and partial differentiation, they have something in common. Now, in partial differentiation, if you are differentiating with respect to a given variable, other variables that is not that particular variable you're working with automatically becomes what? A constant. So that's the thing you need to understand, okay? That's the only concept behind this. So let me bring another thing before we get to the question we have at hand. Let's say for an instance, now I'm giving, okay, let us touch total differentiation, then we'll go back to partial differentiation. If you are given y is equal to 4x to the second power plus, let's say, sine x plus 4. We are asked to differentiate this with respect to x. Okay, find the first order derivative. Now my dy dx will be equal to 4 is a constant, so if I differentiate this, I'll get 2x. 2 times 4 will give me 8x plus, if I differentiate sine x, I will get cos x, so I have cos x. Now don't forget that whenever you differentiate any trig, you differentiate the angle. If I differentiate s, I will have 1, so I have 1 here plus. If I differentiate a number, automatically I'll get what? 0. So this is a constant, I will get 0. So this is this. Now let us go to partial differentiation. If I have f of x comma y is equal to, let's take for instance 4x squared plus, let's say 5xy plus, let's say y, for instance. Now I want to differentiate this partially with respect to x, and I also want to differentiate it partially with respect to y. Remember what I said, in partial differentiation, if you're working with respect to a particular variable, other variables will become what? Constant. Like here 4 is like a variable, but here we know that it is a number. Okay, so if I'm working with x, y will be like a number. Then if I'm working with y, x will be like a number. So we want to differentiate this with respect to x. So there is x here, I can differentiate this. If I differentiate this, I'm going to have 8x plus. Now there is x here, so my constant here now is 5 and what? Y. You understand now? So y is now a constant. Okay, y is now a constant because this is partial differentiation. So once I differentiate x, I will get 1. Remember that y is a constant. If I differentiate this one with respect to x, I will get 0. Okay, so this is the fundamental aspect. Now let us get deeper into this. So let me get a question let's solve. Okay, so make sure you have your coffee or your ice cream. Okay, just feel relaxed, and don't forget to share these videos to your friend. Okay, don't watch alone. So this is the question we are going to solve. Okay, once we are done with this question, I believe you will understand this very topic to the core. Now before we proceed, I would like to explain these things. Okay, I know that some of you, this thing will be odd to you, so let me explain what it means. Okay, this is what you already know. This is what you already know. Now if you have f sub x, know that this is a function of two variables, x and what? Y. Now if you have f subscript x, okay, it has a subscript, this is a sub. Now this thing means that this function was differentiated partially with respect to what? X. So you can still write this as this, d of f of x comma y with respect to x. So that's what this thing means, f sub x of the function. Okay, we differentiated the function partially with respect to x. So this one, f subscript y, means differentiate the function partially with respect to y. Okay, now this one is f sub xx. It means second order differentiation. We differentiated the function twice, that is the second order, partially with respect to what? X. That is second derivative of the function with respect to x. So fxx means second derivative of the function with respect to x. Now fxy means you get the first order of the function with respect to x, then now get the second order of that same function with respect to y. So this means fxy means second order of the function. At first you differentiated with respect to x, now later you differentiate it again with respect to y. So we are going to do all this. Okay, we are going to do all this. Now the last one is the same thing as second order. Fyx of the function means the function was differentiated first with respect to y, df of y, okay, s comma y with respect to y, then with respect to x. So understanding this concept is very, very significant and important, because if you don't understand this, you can't solve it. Okay, you can't solve what you don't know. Okay, so you need to understand that whenever you see this type of thing, this is the way it is. Sometimes they can still change it to g's of x of, let's say, x comma y. This is a function of two variables, okay, x and y only. Sometimes you can see f of x, y, z, that is three variables, x, y, z. So you can still be given something like this. So sometimes you can see g here, you can see k, you can see any letter, okay? So don't be confused. Once you see it, just know that this is what you are expected to do. So now let's solve. So we are starting with the first one. So for the first one, if f of x comma y is equal to x e to y minus sine y over x plus x squared s cubed y squared plus 6s squared y. Now we are asked to get f sub x of the function, okay? That is to say that we should differentiate the function once. We should differentiate the function once, partially, with respect to x. So f sub x of x comma y means that we should differentiate the function with respect to x, okay? So let me make a space here, So this will be equal to, now here is our function. Remember, we're differentiating with respect to x. So anything that is not x is a constant, okay? Anything that is not x is a constant. So I come to this. So this is exponent to what? Y. So this is x. So anything that is not x is a constant. So this is a constant. So exponent to y is a constant times. If I differentiate x, I will have 1. So I have 1. Minus. So I can see x here. So minus. If you differentiate sine, you get positive cos. So I will have cos y over x times. Don't forget, whenever you differentiate any three function, you should also differentiate the angle. So we are differentiating the angle. The angle of this is y over what? X. So I want to differentiate y over x, which is the angle. Okay? I want to differentiate y over x. So you know that in partial differentiation, anything that is not x is a constant. So our constant here now is what? Y. So this is the same thing as y times 1 over what? X. This is the same thing as this, because I want to differentiate this angle here so that I can multiply with this. So this one now is a constant, while this is not the constant. So this is something as y s to negative 1. Okay, look at the one I'm differentiating. This one now is a constant, so this one will remain permanent. I will differentiate this. So if I should differentiate x to negative 1, so I will have y times minus 1 x raised to power minus 1 will give me minus 2. Okay, so this thing now will now turn to minus y x raised to power negative 2, which is something as minus y over x squared. Okay, don't forget, in partial differentiation, if you're working with respect to x, y is automatically a constant. Don't forget, whenever you differentiate any trig function, the next thing you do is that you must differentiate the what? The angle. So our angle here is y over x. So I brought it out y over x. So my constant is y because I'm working with respect to what? X. My constant is y. So I have to, at least let me arrange it in such a way that it will be very easy for me to work on. So this is my y dot 1 over x. So 1 over s is something as s to negative 1. So here now you can still make use of a quotient rule, but that is a very long process, okay? So just make it to be very easy. S to negative 1, the loss of indices, don't forget. So once you differentiate this, minus 1 comes down, minus 1, that is minus 2, then you do justice, okay? You'll get what you need. So once we differentiate this, what we're going to have will be minus y over x squared. So that's what we have. Plus, now remember that we're working with respect to x. So anything that is not x is a constant. So our constant here is y raised to power 2. So when we differentiate s raised to power 3, we get 3s squared. We get 3s squared. Plus, when we differentiate 6x squared y, we are working with respect to x. Anything that is not x is a constant. So our constant here is 6y. So when we differentiate x squared, we get 2x. So this is telling us that our f of x comma y will be equal to e raised to the power y minus times minus will give us plus y over x squared cos y over x plus 3x squared y squared plus this times this will give us 12xy. Here we go. So this is our f of f sub x, the first derivative of the function with respect to x. Okay, now let us get the second one. Now we are also asked to differentiate the same function partially with respect to y. Now that we are going to work with respect to y, anything that is not y is automatically a constant. Okay, it is very simple, very easy. So we go again. Here is our function f sub y of the function, presenting as differentiating the function with respect to y. That's what this thing means. Okay, that's what this means. So now we go into the function. So this has to do with y. This one has nothing to do with y. So automatically this becomes our constant. So s is a constant. When we differentiate exponent, you know that exponent is a function that when you differentiate it, it will come out the way it is. So the next thing you have to do is that you differentiate the what? Power. So when we differentiate e to y, we get e to y times. When we differentiate y, we get 1. Okay? Minus. So we are here. This is sine y over x. So there is y there. Okay, so I can see y there. If I'm not seeing y there, automatically it will turn to what? 0. So any place I'm not seeing y, now that I'm working with respect to, that thing is a constant. If you differentiate it, to get 0. Okay, so I can see y here. If I differentiate this, I will get cos y over x. Now, don't forget, whenever you differentiate any trig function, don't forget to differentiate the angle. So the angle we are going to differentiate now will be y over what? X. And don't forget, we are differentiating partially with respect to y. So our constant here now, this is something as this, y times 1 over x. So our constant here now is 1 over x because we are working with respect to y. So if I differentiate this y, I will get what? 1. If I differentiate y, I will get what? So it will not be 1 times our constant, 1 over x, which will give us 1 over x. So when we differentiate y over x partially with respect to y, our answer will be 1 over x. So that's what we have. Remember the one we did when we differentiated partially with respect to x, we got minus y over x squared. Now we differentiated partially with respect to y, we got 1 over x. So next plus. Now we want to differentiate this partially with respect to y. So anything that is not y is automatically a constant. So our constant here is s raised to the power 3 times. If we differentiate y squared with respect to y, we get 2y. Okay? So let me clean off some things. Plus, we're differentiating partially with respect to y. So our constant here will be 6x squared. Okay? Our constant here will be 6x squared. 6x squared. So when we differentiate y, we get 1. Okay? So our f of y of the function will be equal to, when we multiply this, we'll have s e to y. So minus 1 over x cos y over x plus 2s cubed y plus 6x squared. That is the final answer. Don't forget, this thing is very, very simple. Okay, just give to Caesar what belongs to Caesar. Give to God what belongs to God. Okay, mathematics is based on principle, and if you're a kind of person that obey, you will never fail mathematics. So once they say do it this way, just do it that way, you will not fail. Okay, in partial differentiation, if you're working with respect to x, anything that is not x is a constant. If you're working with respect to y, anything that is not y is a constant. Now for number 3, we are asked to get f sub sx. So it means that if we have gotten f of x, that we should differentiate it again, okay, with respect to x again. So look at our f of xx here, look at it here. This is our f of x, this is our f of x. So for us to get f of sx, we will differentiate this one again with respect to what? X. Okay, we differentiate it again with respect to x. So let us get to it. So our f of xx, so remember that this is f of y, this is where this one ended. So we need f of ss, which is second derivative of the function. So we're differentiating with respect to x again. So this will be equal to, so we go to f of x. We're differentiating it again now with respect to x. So there is no x here. There is no x here. So when I differentiate this now, automatically I will get 0. Remember, anything that is not x is a constant. So this will give me 0 plus. Now look at this. Look at this. This is y over x squared cos y over x. So I have x in both parts. This is on its own, this is on its own. So don't forget the rule of product rule. So product rule will come into play now because x occurs in two places. X is here and x is in the trig function. So product rule will go here. You will now use u dv plus v du. Okay, so don't forget product rule. So let this be my u and let this be my v. So I will keep this constant. I will differentiate this. Now don't forget, when you are doing it, you are still differentiating partially. Okay, so I keep this constant y over x squared dot. When I differentiate a cos, I will get negative sign. So minus sign bracket y over x dot. Remember that you are differentiating with respect to what? X. And once you have differentiated this, once you have differentiated any cos or any sign, once it is a trig function, also differentiate the angle. Okay, so if we differentiate this angle, what are we going to have? Remember, we are differentiating with respect to x. If we differentiate y over x squared with respect to x partially, remember the first time we did it, we got minus y over x squared. Anytime you differentiate cos or sine or tan, don't forget to differentiate the angle. So if I differentiate y over x partially with respect to x, I will get minus y over x squared. So I have done u dv. Now it is now time for v du. So plus, I will keep this one constant. I will differentiate this. So I will keep cos y over s constant. I will keep cos y over s constant. Then I will differentiate y over x squared. Okay, I will differentiate y over x squared. So when we differentiate y over x squared partially with respect to x, what are we going to have? So remember, this is y over x squared. We want to differentiate it partially with respect to x. So this is something as a y times 1 over x squared. So this is our constant. So this is something as a y dot s to negative 2. Don't forget the laws of indices. So when we differentiate this now, we're going to have minus, okay, y is constant. When we differentiate this, we have dot minus 2 x raised to power minus 2 minus 1 will give us minus 3. Okay, so this is the same thing as a minus 2 times y is minus 2y s raised to power minus 3, which is the same thing as a minus 2y all over s cube. Okay, that's what we have. Okay, that's what we have. So we bring it here, minus 2y all over x cube. So don't forget u dv. You keep this one constant. You differentiate this. The reason why I am doing this is because x occurs in two places. In this particular thing, s occurs in two places. Okay, so we respect this s that is here and also respect the other x that is here. U dv. So once I differentiate cos, I get negative sign with the angle. So next, differentiate the angle y over x. Okay, once you differentiate y over x, this is what you end up obtaining. Then keep this constant, then work on this. Once you work on this, this is what you're going to obtain. Don't forget the rules of product rule. Now the next thing is that I will go to this 3x squared y squared. We are differentiating partially with respect to x. Okay, so our constant here is 3. Our next constant here is a y squared. Dot. When we differentiate s to second power, we'll get 2x. Okay, plus 12xy we are working with respect to x. So our constant here is 12 and what? Y. So once we differentiate s, we get 1. So we have 1 here. So once you combine everything we have, so our fxx will be equal to, so this is a minus y over x squared times minus sine y over x times minus y over x squared. So when this multiplies this, we are going to have minus times minus is plus, y times y is y squared, x squared times s squared will give us s to the 4th power. So we are going to have y squared over x to the 4th power, then sine y over x plus, okay, remember, look at this, this is cos y over x times minus 2y over x cubed. So that will give us minus 2y over x cubed minus 2y over x cubed cos y over x. That's what we have here, plus this times this, 2 times 3 will give us 6xy squared, 6xy squared plus 12 times 1 will give us 12y. So this is our answer. As you can see, this is very, very simple. Okay, it is very, very simple. So you can watch this video over and over and over again. Don't forget to practice. They say that practice makes what? Perfect. Okay, as you watch, try and do what? Solve. So let us go to the next question. IV. They say we should find f of x y, okay, sub xy. It means we should differentiate a function that we have differentiated, that we have gotten the first order in x. We should differentiate it again with respect to what? Y. So this and this now, they are the same thing. Just note, anytime you're taking partial differentiation, f of xy is always equal to f of yx. F of xy is always equal to f of yx. So we are going to see this now, okay? Once we solve it, we are going to see it. So now we want to solve question number 4. Get this, that is f sub xy. We are going to differentiate f of x with respect to what? Y. So here is our f of x. Now we're going to differentiate it partially with respect to y. So let me make a space, let me make a space, let me make a space. Let me make a space here. So we want to differentiate f of x with respect to y. We want to differentiate f of x with respect to y. So we want to differentiate f of x with respect to y. This is something as second order of the function which has been differentiated with respect to x. Now we want to differentiate it with respect to y. So this will be equal to, so look at this. They say we should differentiate this with respect to y. So we want to differentiate this one with respect to y. So let's go. This is e to y, so there is y there. When we differentiate e to y, it will give us e to y dot. When we differentiate y, we get 1 plus. I am now here. So I can see y here, and I can also see y here. So I'm going to make use of product rule. U dv plus v du. Don't forget, okay? All these simple knowledge are very, very important. Okay, don't forget. So I will keep this constant and differentiate this. Then I will keep this constant and differentiate this. So I will keep this one constant, y over x squared dot. If I differentiate cos, I will get negative sine y over x. Now don't forget that whenever you differentiate any trig, don't forget to differentiate the angle. Very, very important. So now I am differentiating this angle partially with respect to y, not x. I'm differentiating partially with respect to y, not x. So what I'm differentiating is y over x. So my constant here now is 1 over what? X dot y. So 1 over s is my constant. If I differentiate y, I will get 1. 1 over x times 1 will give me 1 over x. So I'll have 1 over x here. So I have taken v du. Now it is now time for u dv. So I will keep this one constant. Then I will differentiate this one partially with respect to y. Okay, so this is something as a y over x squared. So this is something as a 1 over x squared times y. So my constant now is this because I'm working with respect to what? Y. So if I differentiate y with respect to y, I will get 1. 1 over x squared times 1 will give me 1 over x squared. So times 1 over x squared. So that's what I have. So I have done u dv and v du. So you can interchange it. It is commutative. You can say u dv plus v du, or you can say v du plus, anyhow it will work because it is what? Commutative. Anyone can come first. So I have kept this constant and differentiated this, and I have kept this constant and differentiated this. Now I am here. So we are differentiating with respect to y. So plus, since we are working with respect to y, it means that 3x squared is our constant here. When we differentiate y to the second power, we get 2y plus, we are working with respect to y, so 12x is our constant. So 12x is our constant. When we differentiate our y, we get 1. So let us combine everything we have. So f of xy of the function, so remember that we can be putting this s comma y, this will be equal to e raised to power y. So this times this, 1 over x times y over this will give us y over s cube. So times this minus, it will now give us minus y over s cube minus y over s cube sine y over x plus this times this will give us 1 over x squared, 1 over s squared cos y over x, 1 over s squared cos y over x plus this times this will give us 6x squared y, 2 times 3 is 6x squared y plus 12x times 1 will give us 12x. So this is what we have. Now remember what I said initially. I said that f of xy is the same thing as f of yx. So now let us get f of yx. You know that f of yx means that we should differentiate a function that has been differentiated with respect to y. We should differentiate it now with respect to what? X. So this is our f of y. So they want us to get, we should differentiate this f of y now with respect to what? X. So let us do it. Let me make a space up here. So we want to differentiate this with respect to y. Now remember what I said. I said that if you differentiate a function with respect to x and differentiate it again with respect to y, it is the same thing as differentiating the function with respect to y, then differentiate with respect to what? X. So let us see whether it is true. We have gotten f of xy. Now let us get f of yx. So let us differentiate this one with respect to x. Let us see what will happen. So we need f of yx. We need f of yx. Let's see what happens. Okay, let's see what happens. So the function that they have already differentiated with respect to y, we want to differentiate it now with respect to x. So we want to differentiate this with respect to x. Let us see whether it will give us this. So now we start. This is our f of y. Okay, this is our f of y. So our f of y here is s e to y minus 1 over x. So okay, let me write it out. X e to y, minus this times this will give us 1 over x cos y over x plus 2s cube y, okay, 2s cube y plus what? 6x squared. So this is our f of y, you know. Okay, we didn't compute them, so I have done the computation now. So let us differentiate our f of y with respect to x. Let's see what we are going to obtain. Now we start. When we differentiate s e to y with respect to x, now remember that we are working with respect to x now. So e raised to power y is our constant. So e to y is our constant. When we differentiate s with respect to x, we get 1 plus. So we are now here. This is minus 1 over x cos xy. minus 1 over x cos xy. So as you can see, I have x in two phases. I have x here, I have x here. Product rule, v du plus u dv. So this minus now, I can keep it outside. I'll open a very big bracket to contain everything. So I will keep this one constant. I will keep 1 over s constant. Then I will keep 1 over s constant. I will differentiate this. If I differentiate cos y over x, so cos y over x will give me dot minus sine y over x. So whenever you differentiate any trick, differentiate the angle. Now we're differentiating the angle partially with respect to x, okay? So we're differentiating y over x partially with respect to x. This is something as a y dot 1 over x. So this is something as y dot s to negative 1, okay? When we differentiate s to negative 1, because y is our constant, we get minus y s to negative 2. So something as minus y over x squared. So what we have here is dot minus y over x squared, okay? So that is what we have, okay? We have kept this constant, we have differentiated this, okay? This is what we have. Now next, we'll keep this one constant and differentiate this. We'll keep this one constant and differentiate this. So plus, this plus is still here, okay? There is no space. So plus, we'll now keep cos y over s constant. We'll keep cos y over s constant and differentiate 1 over x. So differentiating 1 over x with respect to x, you know that 1 over x is something as s to negative 1. So it will now give us minus x, you know, when you're differentiating, minus 1 will fall. So it is minus 1 s to negative 1, 2. Which is something as minus 1 over what? X squared. So what we have there is minus 1 over x squared. So when we keep this constant and differentiate 1 over x, it will now give us minus 1 over x squared. So we have done v du plus u dv. Next, we are now here plus. We are now here plus. When we differentiate this with respect to x, so our constant here is 2y, okay, because we're working with respect to x. Our constant here is 2y, so we have 2y dot. When we differentiate s raised to power 3, it will give us 3x squared, okay, to give us 3x squared plus. Lastly, we are here. When we differentiate 6x squared with respect to s, it will give us 12x. So let me make some space. Let me make some space so that we can finalize our work. Make some space, we can finalize our work. So f of y comma of x comma y will be equal to, this times 1 will give us e raised to power y. Now the minus can penetrate now. So remember that there is minus here. There is minus here. Minus times minus, okay. Let me just be like, let me keep the minus outside. So let's obtain this and this. This times this. Minus times minus is plus. 1 times y will give us y over s times s squared will give us s cubed sine y over x. Okay, this times this will give us this plus this times this will give us minus 1 over x squared cos y over x plus this times this will give us 6x, 2 times 3 is 6, s squared y, 6x squared y plus 12x. So f of yx of x comma y will be equal to e raised to power y. So the minus cannot penetrate. Minus times will give us minus y over s cubed sine y over x. Minus times minus will give us plus 1 over x squared cos y over x plus 6x squared y plus 12x. Remember what I said initially? I said that f of xy is something as f of yx. So let us check if they are the same. Okay, the first one of this is e to y, which is this, e to y. Second one is minus y over x cubed sine y over x, which is this. Third one is plus 1 over x squared cos y over x, which is this. Fourth one is plus 6x squared y, which is this. And the last one is plus 12x, which is this. As you can see,
oh yeah,
this is very, very easy and simple. The only thing there is this. Try to obey, okay? Don't just learn this once. Watch the video over and over and over again, okay? Don't forget to share to your loved ones, don't forget to share to your friends, and don't forget to practice, because practice, they say, makes what? Perfect. Okay, thank you very much for listening. I still remain Angel of Maths. Global Tutors, love you. Okay.